Hello students, the question says two identical positive charges, capital Q, each are fixed at a distance of 2a apart from each other. Another point charge Q naught with mass m is placed at midpoint between two fixed charges. For a small displacement along the line joining the fixed charges, the charge Q naught executes simple harmonic motion. The time period of the oscillations of charge Q naught will be. So I'll explain this scenario. We have two charges Q and Q. They are fixed, and in between them I placed a small charge Q, and since it is exactly between them, this charge Q will apply a force to the right, this charge Q will apply a force to the left, and both the forces would balance each other. Now, to create an imbalance, what we did is, for a small displacement along the line joining the charges, the wording is important. For a small displacement along the line joining the charges, that means we are not displacing this charge upward or downward. We are actually displacing the charge along the line. That means let us assume I displaced it slightly towards the right. So I'll redraw this diagram by displacing it slightly towards the right. We can slightly displace it towards the left also, but for our scenario, let us slightly displace it towards right. So once you slightly displace it towards right, we will get new lengths. So if I displace it by a distance of x, so this is the location of my charge now. I have, from its equilibrium position, I have slightly moved it by a displacement x. Now the new length of this charges would be, originally the length was a, since I moved slightly by a, it would become a plus x, the distance between capital Q and small q. The distance between this capital Q and this small q, originally it was a, I have slightly moved by x to the right. So this length would become a minus x. So if I draw the free body diagram acting on our charge q, we have one force due to this towards right. It would be k q q1 k q1 q2 by distance square. It would be a plus x whole square. Let us draw what is a force due to this capital Q on this small q. It would be k q divided by, I think it is q naught. So I will go for q naught only. Q naught divided by a minus x whole square. We can clearly see, since this charge is closer to this mass or to this charge, the repulsion force from this charge would be much greater than the repulsion force from this charge. Due to that, the net force acting on this would be towards left. So you try to move it towards right, but since the net force is towards left, it will again try to get back to its original position. But during that time, it will acquire some speed, and because of that, it won't stop exactly here. It will stop somewhere here. So once you disturb it, it will start to execute simple harmonic motion. You are trying to move right, but the net force is towards the left. So the body will again try to come back. But since it cannot stop here, it will further move towards left. In this way, even with slight displacement, our charge would start to perform a simple harmonic motion. So these are the forces. I have displaced it to the right. As you can see, the force on the left is much greater than the force on the right when you displace it towards the right. So eventually, our particle will try to get back to its original position. Let us find the net force acting on the body. So net force will be k q naught by a minus x whole square minus k q naught by a plus x whole square. So if a plus x whole square, if we get k q naught common, we will have 1 by a minus x whole square minus 1 by a plus x whole square. So we can write this as q naught into a plus x whole square minus a minus x whole square divided by, multiply the bases, a minus x into a plus x, so a square minus x square whole square. So this is similar to a plus b whole square minus a minus b whole square, where you will get 4ab. So q naught into 4a into x divided by a square minus x square whole square. It is given clearly in the question that very small displacement, for a small displacement. So we can say, given x is very small, then it implies that the value of x square can be approximately taken as 0. Since x is only very small, x square can approximately be taken as 0. So based on that logic, we'll get f net equals to q naught into 4ax divided by a square minus 0 square whole square. A square minus 0 square whole square. So you will get 4a q naught into x by a power 4. So net force is finally 4k q naught x by aq. This is the value that we got. But if I wanted to tell it vectorially, I have moved the particle to the right by x. So once the particle reaches here, the net force is acting towards left. So both are in opposite direction. So if I want to represent vectorially, I can write f bar is equals to 4k q naught by a cube into minus x. So its direction is opposite to the direction of displacement, if I want to show along with the direction. So we know in simple harmonic motion, if I find what is acceleration here, acceleration would become 4k q naught by, divided by mass, you will get ma cube into minus x. So we know acceleration is proportional to minus x, represents simple harmonic motion. And here a would become minus omega square into x. Using that logic, we will get omega value equals to root of 4k q naught by m into a cube. So 4k q naught by m into a cube, let me substitute the value of 4 pi epsilon naught. So we can write 4 into 1 by 4 pi epsilon naught into q naught by m a cube. So if we cancel 4 and 4, and we'll get the value as q naught by pi epsilon naught into ma cube. So we finally get the value of omega equal to root of q naught by pi epsilon naught into ma cube. Once we get the value of omega in this way, time period equals to 2 pi by omega. So 2 pi into reverse of this, you will get pi epsilon naught ma cube by q naught. So if I take it inside, you will get 4 pi square epsilon naught ma cube by q naught. I have solved it very slowly so that you understand step by step, but practically while solving, we can solve this problem even more fast. We don't need to draw this diagram this much neatly. We can directly start solving the problem. And this is how we get it. So it would be from the given options 4 pi square epsilon naught ma cube. So 4 pi cube, when pi goes inside, it would become pi cube. 4 pi cube epsilon naught ma cube by Q not Q, which would be our option. Hope you understood how I have solved the problem. Thank you.